So, after the already published videos, so one video is published now in our YouTube MOSAIC channel. The longer video shows the whole flow of using Virtuoso template in this SDF environment and goes in more detail. Then I have made a separate video focusing on the common generator tool. And now building on top of those both videos, I'd like to make a brief video about how to debug your first generator example. And I decided to do this interactively again. So when you're logged into the SDF environment in PyCharm, you have your user home directory, which contains all the generator projects. And we have the Virtuoso template, which contains the framework files. Let's say we have already added, using the gen tool, tgate gen. So here in our home directory, we now have tgate gen. Each generator, to recap, has the structure of Virtuoso templates files, the schematic and symbol, and also the Python side, the scripts which make the generator. So those Virtuoso template files are one input for the generator, and then are the scripts performing the layout and schematic generation currently. So in our SDF environment, in order to get the gen tool working, the structure is now as follows. The init file is just a pure just has the purpose of providing a Python module, so that tgate gen, this directory, can be imported higher up the hierarchy as a Python import. In our SDF environment, it no longer contains the main script. Rather, the gen tool will look in the Python module for a design class. And this design class can be found in DesignPy. We see that this design class is inherited from DesignBase, which, for example, offers common features like the dumping and LVS checking, which are exposed later by the gen tool. The design class initializes the parameters. The parameters are parameter classes, which are configured here in these class methods. So there are a couple of methods expected. One class method is this parameter class, and it returns the tgate params class. We can see here this comes from the params file. So here we have a params.py file, and from this params.py we import the tgate params, and they are then returned here as the parameter class. Also, we can see layout.py is imported here, and we import the layout class as tgate layout, and we can see there's another class method of the design, which, like the parameter class, also the layout generator class can be obtained. And there's another method which returns the name of the generator, because the gen script will try to find a class design within the design module. So that's the same for all generators. And to have the effective generator name, this package method is used to then obtain the name of the generator, like tgetgen. And that's about it for the, and then we have the parameters, which are of these, which are objects of this parameter class. We can see in the initializer, there's a default initialization. And these defaults are, when we look at the params file, you can see we have this parameter file with docstring documentation, and then a set of typed parameters here. And we can see there's also, if you look at the structure here, there's also there are also factory methods which provide an instance set up for FinFET and default and another factory method which provides a default instance set up for planar. So in our bootcamp environment here, we are using these FinFET defaults here, and this just constructs an object of this parameter class set up for use with FinFET. So for example, when we use gen, when we look at the generator tool, we see we have this gen dump, for example, where we can dump the default parameters. This will currently use exactly these factory class method to create first a params object with these defaults and then dump it to YAML. So that's about it for the design class. So the class which is most interesting is the layout generator. We can see the layout generator is derived from analog base. We have basically one method that must be implemented, which is called draw layout. Here we can see that the params object is accessed. It is of type tgate params, and all the layout generation, the use of helper classes like rows and transistors and lists of rows, row lists. Then the use of the analog base helper method draw base can be seen here. Wiring is done. At the end, we can see the schematic parameters are extracted, which are later passed to the schematic Pi. And this class tget here at this point can be used in higher level layouts. So in order, if you want to start debugging layout generation, I would recommend setting a breakpoint here and then simply to debug the generator tool. And the way you can do this, there are already some templates, but let's do it from scratch. In the Virtuoso template area, we have BAG2 methods, and in BAG2 methods, we have the SAL module, where we have also the generator Python script. And we can say simply debug debugged, and this script here is used. Also, we can, of course, let's say we don't have this, then basically we set up a configuration where this generator Python script is the script, and the parameters are exactly what you would pass in the command line. So make tgetgen. In case you would have a parameter file, as we saw earlier in the other video, you could pass a path to a like my params YAML here, but in this case we just want to debug layout generation. Then after we have configured this, we can then, of course, start Virtuoso, which needs to be running as a precondition. We can simply use our from our greeting message. So we can simply use the steps documented in our greeting area where we have this hint that Virtuoso can be launched using this Virtuoso wrapper script. So we simply do this, and then Virtuoso starts up, and this is very important that at the end of in this command interface window, it's important that this BAG skill server has been started. So, because otherwise the Python script can't talk to Virtuoso properly. Now that the skill server is running and the templates can be found, TG templates here, for example, we can see we don't have the generated output yet. Like for Inverter 2, we already have from a previous run the generated output library here. For TGate, this is not yet the case. But now that we have set up our debugging profile and also set our breakpoint here, we can now simply go here and see that the generator class is detected properly. And now we already are at this breakpoint here in PyCharm. And here you can look at objects and variables and their values. But also if we, for example, use these commands here to step over, we can see that here we have now like, let's say like a comment. We can now see the actual object here. In this case, the L value is params, and we can see the investigate the variables and the values of those fields within this params object. And this way we can step by step execute the program and see what it does. If we want to go into, for example, this row class, if we want to see what this is in the SAL module, a helper class for rows. We could simply press Control click, so hold the Control key and press click, and then this row class will be opened, and we are now in the initializer. If we want, so in the debugger we are currently here. If we want to step into this method, we can simply do step into here. We need to, and now we are in this initializer I just showed you, again with all those actual types of the parameters of this method signature here already filled. And again, here we can do step over and step over. And in order to return, we just do step out here. And now if we do step over, we are again here following the sequence of statements here in this layout file. So that way you can debug layout generation it's also possible, for example, let's say you are interested in a special section. For example, perhaps here we want to see what the transistors are, and what this transistor info is. We can simply add a breakpoint here at this point, and then here when we do resume program, execution will continue up to this point. Then here we can look at this TX info and see what has been set up here. Yeah, so that's the way I recommend debugging your perhaps for first the existing generators and later your own generators. Like I said, when you have this profile, you can also duplicate debugging profile configurations. If you have, for example, your own generator, you would then change the generator argument here to your, let's say, example gen to have the generator script run your generator. Okay. Thanks for your attention and have a great day.